Working as R&D engineer at Theory to Practical. Our company makes the education more practical oriented and to bring the passion and confidence among students towards education. With this vision in our mind, we are going to enjoy this video regarding the theoretical and practical aspects of SCADA system. To understand this practically, we have also made one project and we are going to have the demonstration of the same. In this video, we are going to cover these topics. First is what is SCADA, then building blocks of SCADA, then the demonstration of our project, circuit description, software description, understanding protocol, application of SCADA, and what next to learn and do. Now we will discuss these topics in detail. So first is, what is SCADA? SCADA stands for Supervisory Control and Data Acquisition. We will understand it by an example. Suppose I am an employee of one company and my job is to make sure that this bulb should glow always. And I have provided this switch and this lux meter. Lux meter measures the intensity inside the room. And I have given instruction that if the light goes below the certain level, then only I have to switch on this bulb. Now, to complicate this situation, suppose there are 2000 such bulbs situated at different locations. There are two ways of doing this. One is to have 2000 such manual operators, and second one is to have the intelligent instruments which will be placed at all these 2000 locations. They will get data from the lux meter and take the action accordingly. That is, they will switch off and switch on the bulb accordingly. Not only this, they will also send its data, that is on-off status, to the central location. The second way is called SCADA. Now we will discuss our next topic, that is building blocks of SCADA. Here we have a very good representation of building blocks of SCADA system. So here we have sensors, transmitters and control system. Then we have remote terminal unit called RTUs. Then communication bus. Then master station or master terminal unit. And finally data processing unit. Now we will discuss each these topics in detail. So first one is sensors, transmitters and control system. So what is sensors? Sensor senses the physical properties like flow, temperature, pressure and convert it into an electrical signal like voltage or current, which can be understood by the RTU, that is remote terminal units. Okay. Now we have control system like pneumatic valve or relay or contactor, which will take action from remote terminal unit and take the mechanical action accordingly. Next building block we have is remote terminal unit, that is RTUs. RTUs take data from the sensors and give it input to the control system. It also communicates to the master terminal unit via communication bus. It will send its data to the master terminal unit and also gets command from it. The examples of RTUs are, one is PLC, that is programmable logic controller, or the microcontroller based embedded system. Next, we have in our building block is communication bus. This is a mode of communication between RTUs and MTUs. It can either be wireless or wired. The example of wire communication is LAN wire, your RS485 cable and your optical fiber cable. The examples of wireless communications are Bluetooth communication, your RF communication and your Zigbee communication. Now next, and there is one protocol which has to be followed by every member of RTUs and the MTUs, and the examples of some of the standard protocols used are Modbus protocol and Canvas protocol. Next, we have MTUs, that is Master Terminal Units. It's communicate to the RTUs, all the RTUs via communication bus. It collects their data and send them instructions. It also communicates to PC and is sending its data to the PC and also getting data from the PC. Next, we have data processing unit, that is the final building block. It is basically a computer which takes data from the master terminal unit and it presents the data in user understandable format like Excel file, like pie charts and like graphs. It makes the data available on mobile phone, on SMS, on printer and on the website. Let's have a look on the advantages of SCADA system. First, it improves system performance and reliability. Second, it makes the system simpler, faster and organized. Third, it makes the system automatic without the need of much human intervention. And finally, it reduces the operating cost. Now we will get the demonstration of our project. So this one is a hardware, and this one we have implemented here slave 1, or we can say plant 1 or RTU 1. This one is slave 2 or plant 2 or RTU 2. And this one is master, that is a master terminal unit. And here this one is RS485 connector, or we can say junction. And this one is your USB TTL to USB converter, and it is giving data to the PC. Now we discuss each of them in detail. So first come to RTU1. So now this one is a microcontroller unit, which is measuring this value from this port. This port can be varied using a screwdriver. So right now, if I will vary it using a screwdriver, then its value will vary from 0 to 255. Now this value is going to this microcontroller, and this microcontroller is displaying this value in this 7/7 display. Now I will show. Now I am increasing this value. Now I increase to 16 and 17 here. Okay. Now this one is a RS485 chip, which is used for RS485 communication. It is there in all these PCBs, and it is sending its data. This microcontroller is not only displaying but also sending its data via this RS485 bus. So same hardware description is for this slave 2, remote terminal unit 2, and it is also displaying its value. It is taking its value from this port, and it is sending its data also. So here it is 17 and here it is at 19. Now come to the master terminal unit. So this one is your master terminal unit, and it is displaying the value of slave 1 and slave 2, 17, 19, and this 145 is actually the command it is getting from the PC. So based on that, it will send command via this RS485 bus to slave 1 and slave 2 for switching on, whether they have to switch on or off their relay. Now this one is relay unit, and this one is your bulb, which are connected to the NO and C terminal of this relay. These are transformers which is converting or transforming 230 volt to 9 volt AC, and this one is your bridge rectifier circuit, and this one is 7805 for regulated power supply. This 7805 is giving this supply 0 to 5 volt DC, which is being used for this master unit, this slave 1, slave 2 and slave 1. And this transformer is also generating 0 to 5 volt DC via this 7805 circuit here, and this is being used for powering this relay. And similarly here this transformer is generating 9 volt AC, then it is converting here this using this bridge rectifier circuit, then this regulated power supply, then this relay is getting power, and this relay is getting control signal from slave 2 via these point, and this one is getting from this point here. Now we will discuss the software description of our project. So this one is our software, this design and development of SCADA system, and this runs as a .exe file, and we require .NET runtime, which can be downloaded from Microsoft sites, and it is free. It runs on .NET runtime, and this one is your boiler 1. This is representing plant 1 or slave 1. This one is representing boiler 2, or we can say plant 2 or slave 2. And this one is control room for data processing, which is representing itself, the system only. And this text box has value 17, so it is getting from our hardware and is showing here. And similarly here it is showing the temperature 19 getting from this hardware of this slave 2. And we have set here a lower limit and upper limit, and here also. And if limit, you can see this limit is below the lower limit, so this gets red, lower limit signal. And here, as it is between this upper and lower limit, so it is both are green here. And this one is basically user can set its username and password, and it will get the value of boiler 1 and boiler 2 in its email at the periodicity of every 5 seconds. Now this one is log file text box. Oh, this one is message that mail has been sent just now, and this one is a log file. So here user can give the path of the file, of the Excel file, so where the data will be saved with these readings and with the date and time. Now we will discuss this graph section. So here this graph is plotting versus temperature versus time. So now right now channel 2 is selected, which has value of 19. Now I selected channel 1, so it comes to here 17. So here we are getting temperature versus time for boiler 1 and boiler 2. Now we will discuss the email facility of this software. So we got one mail from our software, and its subject is email alert for SCADA system, and it is giving the project name and the value of boiler 1 as 17 and value of boiler 2 as 19 at our email ID theory2practical@gmail.com. Now we will discuss the Excel file generated by this software, SCADA.axls file. So this software has created this file, and it has created 4 columns: date, time, boiler 1 and boiler 2. And here we can see the date, time and reading of boiler 1 and reading of boiler 2. So here in this Excel file we are getting the readings of boiler 1 and boiler 2 with date and time. Now we will discuss our next topic, that is understanding protocol. So what is the protocol? Protocol is a set of rules or the procedure that has to be followed by every member of the communication system. Here also we have used a protocol. Now let's understand it by an example. Suppose there is a group discussion is going on among 5 members, M, A, B, C and D, and among them M is the master. Now M will initiate the GD by asking A to express his views. Now while A is expressing his views, all are listening to him. After that, now M will ask B to express his views, and so on. So here what we have seen? Here we have seen at one point of time only one is speaking and all are listening. Second, M is coordinating the discussion, and this discussion goes smoothly. So here also we have used this protocol. Here the master will initiate the communication by asking slave 1 to provide its data. Now after taking data from slave 1, it will ask slave 2 to provide its data, and after taking data from slave 2, it will send the data to the PC, and it will also take the command from the PC, that is the on-off status of relay 1 and relay 2. Now we will understand this by a graphical representation. So here we have a graphical representation of our timeline of our program. Here this one is timeline, it is representing time, and here we have shown the enable and disable status of the receiver and transmitter of master, plant 1 and plant 2. What do we mean by enable and disable is like RX, that is receiver, is receiving, and or we can say it is taking, and when we say TX, that is transmitter, it is transmitting, it is giving. Okay, so we have here, like in this step, we have made the RX enable and TX enable, and this one is step A, step B, step C, step D, step E, and then this cycle will repeat. Now in this step A, in first 150 millisecond, what will happen, that the TX, that is transmitter of master, is enabled, while that of plant 1 and plant 2 are disabled. And here the master is transmitting the address and relay status of plant 1. In next step, that is in step B, in next 150 millisecond, the TX of plant 1 is enabled, while TX of master and plant 2 are disabled. Here the plant 1 is transmitting its data and master is receiving. In our next step, that is in step C, in next 150 millisecond, now the TX of master is enabled while that of plant 1 and plant 2 are disabled, and now the master is transmitting address and relay status of plant 2, and after that in step D, in next 150 millisecond, the TX of plant 2 is enabled, and now it will take its data and the master is receiving. In our step E, what will happen? We have made this RS485 bus inactive, and now the master is directly communicating to the PC via RS232 cable or USB cable, and it is giving the data of plant 1 and plant 2 to PC, and it is also getting the data from PC, that is the relay status of plant 1 and plant 2, and after that the cycle will repeat, and now we have here step A. Now we will discuss what accept protocol we have used in our project. In designing this protocol, we have some design considerations. First is how master or slave will know that what data they are receiving is addressing to them or not. Second, how master or slave will know that whether I should switch on or off my relay. And third is, suppose if data is get corrupted due to some reasons like external noise, then how the system will know, or how the master or slave will know whether I should discard this data or not. We have taken care of these design considerations in our project. Now we will see how master and slave will set its data. Master and slave communicate with each other using a byte, which is a 8-bit data. So here this one is byte, and it is bit 7, bit 6, bit 5, bit 4, bit 3, bit 2, bit 1 and bit 0. Now we will see first how master set its data. So the bit 0 and bit 1 represents slave's address. If it is 01, then it corresponds to slave 1, and if it is 10, then it corresponds to slave 2. If master wants to address slave 1, then it will write here 01, and if it wants to address slave 2, then it will write here 10. Now come to bit 3 and 2. These are not used in our communication, and this come to this bit 5 and bit 4. They represent relay status. So if it is 1 1, then relay is on, and if it is 0 0, then relay is off. Suppose, for example, master sets here 1 1, and here at bit 1 bit 0 it sets 1 0. That means that it wants the relay of slave 2 should be on. Now come to bit 7 and bit 6. They are identifier of master. See, if slave is getting at bit 7 and 6 different from 0 1, that is like if it is getting 0 0, 1 1 or 1 0, then it will understand that this data is corrupted data and I should discard this data. Now we will see how slave will set its data. So first I will tell you, the slave has to send the 8-bit data. So what it will do, first it will divide its 8-bit data into two sets of 4-bit data called nibble. So here, and it will keep this nibble data at bit 3, bit 2, bit 1 and 0. So we have written here upper or lower nibble data. That is in this location, bit 3, bit 2, bit 1 and bit 0. Then this bit 4 is a indicator of upper or lower nibble. So if it is upper nibble, then it will write here 0, and if it is lower nibble, it will write here 1. Now come to this bit 6 and bit 5. These are slave's address. If slave 1 is sending the data, then it will write here 01 at 6 and 5, and if slave 2 is sending the data, then it will write 10 here. Now come to bit 7. Bit 7 is identifier of slave and it should be set 1. If slave sets here 1 and due to some external noise, this data is being corrupted, and if master is getting 0 at bit 7, then it will understand that this data is corrupted and I should discard this data. Now we will see how slave will set its data by an example. Suppose the data to be sent is 0B00111010, and now slave 1 is sending. So what slave 1 will do, it will divide its 8-bit data into 2 sets of 4-bit data. So, and it will call upper nibble and the lower nibble. Here this one 0011 is upper nibble and 1010 is lower nibble. Now it will place these nibbles into 2 sets of bytes. First is, this one is first byte, this one is second byte. So it is keeping this lower nibble in this first byte and this upper nibble into the second byte. Now this bit 4 corresponds to the indication of upper or lower nibble. So as this corresponding to lower nibble, so it will set here 1, and as this corresponds to upper nibble, it will set the 4th bit as 0 here. Now as we know, this bit 6 and bit 5 correspond to the address of the slave sending the data. So as now the data is being sent by slave 1, so it will write its address as 01. Suppose data has to be sent by slave 2, then it will write here 10. So we can see here it is 01 here and 01 here. Now come to the last bit, that is bit 7. It corresponds to the data verification. So here it sets here 1 and 1. Suppose if master gets this data and it gets here 0 at this bit 7, so it will understand this data is being corrupted and I should get here 1, but I am getting here 0. So it will discard this data. Now we will see how slave will set its data by an example. Suppose the data to be sent is 0B00111010, and now slave 1 is sending. So what slave 1 will do, it will divide its 8-bit data into 2 sets of 4-bit data. So, and it will call upper nibble and the lower nibble. Here this one 0011 is upper nibble and 1010 is lower nibble. Now it will place these nibbles into 2 sets of bytes. First is, this one is first byte, this one is second byte. So it is keeping this lower nibble in this first byte and this upper nibble into the second byte. Now this bit 4 corresponds to the indication of upper or lower nibble. So as this corresponding to lower nibble, so it will set here 1, and as this corresponds to upper nibble, it will set the 4th bit as 0 here. Now as we know, this bit 6 and bit 5 correspond to the address of the slave sending the data. So as now the data is being sent by slave 1, so it will write its address as 01. Suppose data has to be sent by slave 2, then it will write here 10. So we can see here it is 01 here and 01 here. Now come to the last bit, that is bit 7. It corresponds to the data verification. So here it sets here 1 and 1. Suppose if master gets this data and it gets here 0 at this bit 7, so it will understand this data is being corrupted and I should get here 1, but I am getting here 0. So it will discard this data. Now friends, we will discuss our next topic, that is application of SCADA. So SCADA is used in hotels, in residential buildings, in cinema halls for monitoring electricity, refrigeration, air conditioners, lighting and the entry points. It is also used in electricity power generation, transmission and distribution for monitoring electricity and to regulate the operation of circuit breakers. And it is used in manufacturing industries for quality inspection, for monitoring various processes. It is used in water and sewage plant. It is used by state and municipal units for maintaining and monitoring the water flow, for reservoir level, for the maintaining or monitoring the pressure in pipes. It is used in mass transport like metro train for monitoring electricity, for automate traffic signals and to locate the trains and buses, etc. Now friends, we will discuss our next topic, that is what next to learn and do. So I would suggest you to go to some factories or some hotels and get an experience of how they have implemented the SCADA system. And second, I would suggest you to find a way or think and find where you can apply this SCADA system. And third, I would suggest you to learn this Modbus protocol. This is very important and is being implemented in industries. And fourth, I would suggest you to work on getting the SCADA readings on your mobile phone as a SMS. Because nowadays mobile phone, everybody wants to have reading on their mobile phone. Please let me know on which engineering topics you want me to make such videos, and if you like this video, please share this video with your friends on your Facebook account or other social networking sites. You can contact me at theory2practical@gmail.com. You can visit our website for more details, www.theory2practical.com. I will meet you in my next video. All the best. Keep enjoying.